The time it takes to merge sort n elements is the time it takes to merge them, which is linear, plus twice the time it takes to sort each half. The time it takes to sort one element is trivial, or constant time. So now we have an expression in terms of n and t of n over 2, but what is t of n over 2? Well, one way to figure it out is to substitute n over 2 into this original equation. That's going to give us t of n over 2 is equal to n over 2 plus 2 times t of n over 2 over 2, which is n over 4. Therefore, if we multiply through by 2, we get n plus 4t of n over 4. Now that we know what 2t of n over 2 is, we can substitute that back into this original equation, and that'll give us the time to do the merge sort on n is n plus 4t of n over 4, or the time it takes to sort a quarter of the data. This simplifies to 2n plus 4t of n over 4. So now we have an expression in terms of n and the time it takes to sort a quarter of the data. But how long is that? We can do the same kind of trick again in order to figure this out, substituting n over 4 into the original equation. T of n over 4 is equal to n over 4 plus 2 times t of n over 8 now. Therefore, multiplying through again, 4t of n over 4 is equal to n plus 8t of n over 8. And now we have the thing we were looking for, the value of 4t of n over 4. We substitute that back in, and now we'll have an equation of t of n is equal to 2n plus n plus 8t of n over 8. That simplifies to 3n plus 8t of n over 8. We can carry on doing this for a while and see that we will get 4n plus 16t of n over 16, 5n plus 32t of n over 32, etc. And eventually we can generalize to k times n plus 2 to the k t of n over 2 to the k, where k is the number of levels of merge sort calls in the recursion. Suppose we start with 64 elements that we want to sort. That's going to get chopped up into 2, each of size 32. The 32 elements are going to be chopped up into 2 blocks of size 16, etc. The next calls to merge sort will have 4, 2, and 1 elements in them. So that's 1, 2, 3, 4, 5, 6 levels of calls to merge sort. If we erase those and start counting from the bottom up, we'll see that we have 0, 1, 2, 3, 4, 5, 6 levels of calls to merge sort. Every extra level of recursion allows us to handle twice as many elements. So when we add 1 to k, we multiply n by 2. This is an exponential relationship. K is the base 2 logarithm of n, and n is 2 to the k. Substituting this value of kn gives us the log base 2 of n times n plus n times t of n over n. This is n times the log base 2 of n plus n times t of 1. Now we know that t of 1 is just 1, so this simplifies to n log base 2 of n times n plus n. Discarding the lower order terms and ignoring the base of the logarithm, which just works out to a constant, this algorithm's runtime is in the order of n log n.